Hello everyone and welcome to the highlight of your day, proportions. We are going to be talking about what they are and how they are used and just get into more stuff about it and some practice and stuff. But we are going to start out with, as I said, what is proportion? The purpose of this video is to set you up for similar triangles, but you can use it for proportions in general if you want to. And here we go, just with a little bit of notes, proportions. For the purposes that I use them, I talk about proportions as fractions. You could technically also have them as a ratio, in which case you have a number and then a colon, the two dots, and then another number. But like I said, for us, we are going to be using fractions. So proportions are fractions that are the same when simplified. That's how we are going to be using them, especially with similar triangles. So for example, I have 3/4, and let's say I wanted to make something proportional to that. Then 3/4, I know, is the same thing as 6/8. I recommend pausing the video and thinking for yourself about how I knew that, or how you would know that. How did I know that was 6? So like I said, I recommend pausing the video, thinking about it. When you think you have an idea, then unpause it. Well, the answer, at least for me, is that I found that if I multiply the bottom by 2, I get 8. So if multiplying the bottom by 2 gets me 8, then multiplying the top by 2 would get me 6. And these things would be proportional. If you reduce 6/8, you would divide them both by 2, and you would just get that again. So then the question goes, well, what if I wanted to make it 15 instead of 6/8? So like, what would you have to do to 3 to make it 15? And in this case, the answer is multiply by 5. So then, what number would go on bottom? And that would be 20. So these three numbers are proportional to one another. 3/4, 6/8, and 15/20. They are proportional. They are the same when simplified. And that's it. That's what proportional means. Here I have some more practice. Here I have 24 over 16 equals 12 over what? Well, 24 to 12. So for me, in this case, I'm not multiplying by something to make it bigger. It looks like I'm cutting it in half. 24 divided by 2 is 12. So if 24 divided by 2 is 12, then 16 divided by 2 would give me 8. So 24 over 16 is proportional to 12 over 8. And if I wanted to simplify it more, it looks like I can divide them both by 4. And 12 divided by 4 is 3, and 8 divided by 4 is 2. So completely simplified, they're both 3 halves. So those are all proportional. Technically, there are an infinite amount of proportional fractions, because you could multiply this by any number on top and bottom and you would get a different fraction. So proportional is just talking about how small something is compared to how big it is. So you can make a number bigger and bigger and bigger in proportion to each other. Here are 2 practice problems. I recommend pausing and seeing if you can figure it out. Here, you take 40 to make it 8. It looks like you divide by 5. So you would divide this by 5 and you would get 5. So x equals 5. So using this kind of thinking, you can sometimes just get the answer. You might notice that dividing by 5 will get you the answer. In this one, 21 to 63, you might be able to figure out what multiplies to get that. We're going to get to happen when you can't, but in these ones, it turns out 21 times 3. So times 3 is 63. So 10 times 3 is 30. So sometimes you can do that. It's a good way to do it because it's good math thinking. Number sense, that's the word. But sometimes you can't. When comparing 2 proportions, the ratio comparing 2 measurements is called the scale factor. What is the scale factor for the above problems? Well, it's what we were talking about up here. There was this special number 5 that we were dividing by, and there was this special number 5 that we were dividing by. So in this case, if you want to talk about the original, the scale factor was like a 40 to 8. But when you simplified it, when you divide them by 8, I'm sorry, in this case 8, it would be 5 to 1. So the scale factor is 5 to 1 in that case. Or sometimes you just do 5 over 1, which is 5. But scale factors are usually written like this. You might have seen it like if you ever make models of something, like model airplanes is a popular thing with a bunch of people. They'll have an actual scale factor. They'll say it's 7 to 8, or more likely something like 1 to 100 scale. And that just means for every like 1 inch, in real life it would be 100 inches. But you know, sometimes it gets much bigger than that. Like if you have either an airplane or a train or something like that that's a model, it would be more like, you know, 1 inch is supposed to be like 15 feet or something like that. But there'll be a scale factor, which means that the figure you have is the exact same shape, but it's a different size, and that's a scale factor. So this would be like 1 inch is 5 inches, or for every 5 inches, this one's a 1 inch. So you divide by 5. That's it. Sometimes it is not at all obvious. How do you solve for x? Like this one, right here. 3 goes to 4. What do you have to multiply 3 by to get 4? No. So the question is, how do you do that? And it is something called cross-multiplying. Cross-multiplying is something you do when you have 2 fractions equal to each other. I'm going to write that. 2 fractions equal. The reason I'm doing that is because I teach algebra sometimes. And a lot of people forget this fact, that this only works when the 2 fractions are equal. I have a lot of students who will start cross-multiplying when you're adding fractions or dividing fractions or subtracting fractions, but cross-multiplying is only a thing when they are equal. So please remember that. Cross-multiplying is when 2 things are equal. And what it says is that if you were to multiply one diagonal and then you multiply the other diagonal, those 2 things are equal. So in this case, 32 times 2 is 64. And x times 8 is 8x. And then if you divide by 8, you just get the number 8. So x has to be 8. And there you go. In this example, you can see that's definitely true because 8 times 4 is 32. 8 times 4 is 32. And then 2 times 4 is 8. So you didn't have to cross multiply in this one, but it does work. Multiply equals multiply. Same thing here. Like I said, it wasn't obvious, so we'll see what happens. 5 times 4 is 20. And 3 times x is 3x. So to solve for x here, you'd have to divide by 3. Oops. And you get x is equal to 20 over 3, which is not a whole number. It's a fraction, which is why it was not at all obvious. And there you go. That's the answer. That's all you can do. Some practice problems. Unlike the previous ones, these have more than one thing. Like this has a 5x instead of an x, but you are still going to be cross-multiplying. It is still going to be 6 times 5x equals 5 times 2. So 6 times 5x is 30x, and 5 times 2 is 10. Divide by 30 to get rid of that, and x equals 10 over 30, which reduces. Right? They both divide by 10, so you would get 1/3. And that's it. Number 2, same thing, but with one extra thing. Notice here it has a plus sign. This one it was multiplying 5 times x, so we could just multiply 6 and 5 to get 30. But that is not the case here. Something that I am very, very, very strongly attached to when it comes to binomials, things with two terms, is to always put it in parentheses. I am very, very paranoid / in love with the idea of putting those in parentheses. It doesn't matter what unit you are on, it doesn't matter what subject you're on. Anytime you see a binomial, it tends to be good to put it in parentheses. That way, when you cross multiply, you'll cross multiply correctly. Because when you do 8 times x plus 6, you need to put the parentheses there. 9 times 6 is 54. If you do not put the parentheses there, then people are very tempted to say, well, 8 times x plus 6 is 8x plus 6, right? 8x plus 6. And they'll write that, but that is completely wrong. This entire thing, x plus 6, has to be multiplied by 8, which means the 8 actually needs to be distributed. So you don't get 8x plus 6, you get 8x plus 48, which is a huge difference. And then you would solve from there. This is going to be 6. So x equals 6 over 8, which simplifies by 2 to 3/4. So that's all you need to know to try number 3. So pause and try number 3. For number 3, put this in parentheses. You'll get 4x minus 1 equals 6 times 8, which is 48. Distribute this to get 4x minus 4. Add 4 to get 52. And divide by 4 to get 13. Pretty sure it's 13. Yeah, it's 13. So the answer is 13. The difference with numbers 4 and 5 is that it has more than one x. The algebra is going to be a little different, but the process is still the same. You still need to put all these things in parentheses. You're still going to cross multiply. To get 10x equals, and then once again with the parentheses there. After, excuse me, after distributing. Once again, if the algebra is going too fast, feel free to pause or rewind. So that was distributing. So the thing that's different for this one's algebra is that it has x on both sides. Remember that when you have x on both sides of the equation, you have to move it over. So you would need to subtract the 7x over to get 3x, because you need x on one side and only one side. So that's the difference. You had x on both sides, so you had to move it over. And then divide by 3. That's going to be 14. Once again, pause, try number 5. You did pause, right? I did tell you to pause. You didn't just ignore me and keep listening, did you? I know you wouldn't do that. You wouldn't do that to me, right? So this will be a 4 and an x plus 9. This will be a 6 and an x plus 5. Next up, we will distribute 36. 6x plus 30. So once again, x is on both sides. It doesn't matter which one you move over. You can move the 4 over to the 6 or the 6 over to the 4. It does not matter which one you do. I'll just go ahead and subtract 4 because it's the smaller number. So you get 36 is equal to 6 minus 4 is 2. Subtract 30 from both sides, and you get 6. Then you divide by 2, and you get x equals 3. Ta-da! Okay. That's it for that in the practice. I think I'll leave it off there for this video. So hopefully this was helpful. There's everything if you need to see it. And there's everything with here if you need to see it. Have a good one.